We have Professor Ashwini Kumar sir, professor from VIT. So about sir, Ashwin Kumar Cherukuri sir is a professor at Vellore Institute of Technology. His research interests include information security and machine learning. Dr. Ashwini Kumar sir earned the Young Scientist Fellowship from Tamil Nadu State Council for Science and Technology and was awarded the Inspiring Teacher Award from the Indian Express. He has worked on various research projects funded by the Government of India's Department of Science and Technology, Department of Atomic Energy, and the Ministry of Human Resources Development. Dr. Ashwin Kumar sir has published more than 150 referred research articles in various national, international journals and conferences, and is an editorial board member for several international journals. He is a senior member and distinguished speaker of the Association for Computing Machinery, a member of the Institute of Electrical and Electronics Engineers, and vice chair of IEEE Task Force on Educational Data Mining. He is a distinguished speaker of ACM. He served as Dean, School of Information Technology and Engineering, VIT Vellore. Welcome, sir. Welcome to this short-term course program, sir. Please proceed.
Thank you, madam. Okay. So my screen is visible now, madam?
Yes, sir.
Okay, and my voice is clearly audible?
Your voice is also very clear, sir.
Okay. So first of all, I would like to thank Iyengar sir for inviting me to this faculty development program organized by sir at the CDD Institute. In fact, Iyengar sir was my doctoral committee member, and his support and his encouragement during my research was highly helpful to me. And I'm not sure how many of you are are utilizing the experience and expertise of Iyengar sir. I can still remember the days where we all used to be little afraid for the strictness of sir, and he used to be very particular about the quality of the work. So with such dedication, we used to get guidance. So thank you, Iyengar sir, for the opportunity given to me to deliver a talk to the faculty as well as the leading scholars of the institute.
Definitely, I will convey all this to Iyengar sir.
Oh,
Actually,
okay.
Iyengar sir went for some work, sir. He will join in the middle of the session, sir.
Fine, sure. Also, I would like to thank the organizers for arranging this talk. So, my talk is on using lattice theory principles for data analysis. As all of us, we are using, highly dependent on the data science, machine learning, artificial intelligence, and it has penetrated to our day-to-day activities. So let us today learn about a technique that has originated from mathematical lattice theory principles, which we call it as the formal concept analysis. Let us understand the basics of this formal concept analysis and how it has originated from lattice theory. Then subsequently, we will focus on how the data analysis can be performed and knowledge representation can be performed using the lattice theory principles, and also about various applications. So my whole talk would be focusing on, I will give you a brief prologue of what is the role of mathematics. We all should understand, being the computer science or IT students. So I will be talking about the role of mathematics in computer science, because this is very important nowadays, in the sense that we get carried away, or we get too much of focused on the focused on the service sector in the IT industry, rather than focusing on the true the computer science of the discipline. Now, by just focusing on the service sector in one way, we are able to attract the job, but at the same time, our contribution to the growth of computer science is getting minimized. In that regard, we all should actually think, especially the postgraduate students, research scholars, as well as the faculty members should think about what is the role of mathematics in computer science, and how actually we need to think whenever we are learning a particular topic, or whenever we are teaching a particular topic. If we can understand the maths behind this, the core algorithm or the technique, our understanding will be more deeper, and the more we can contribute to that particular discipline. So in that way, our research can progress. I will show you all the developments that what we have done, especially from the understanding the lattice theory, the principles and all that. So I'll be talking of the mathematical lattice theory, but very briefly. Then I'll be focusing on the formal concept analysis technique. Then from that particular technique, how to generate the concept, what is the concept lattice, then what is the attribute implications. All of us know about the association rules in the data mining. So how the attribute implications or the association rules can be generated using the lattice theory principles. I also talk about a quick case study about what we have done and our particular research in FCA and the applications. So all this is visible now, madam?
Yes, sir.
Yeah, yeah, yeah. So visible and audible, right? So I can proceed. There is no disturbance. Correct?
Yes, sir.
Okay, ma'am. So see, we all should understand that the computer science actually is a very young discipline when compared with the other streams, other domains. It has roots in various fields. So whether it is electrical engineering, whether it is in electronics. So as a science, it has roots in mathematics. So this particular slide gives you about, we learn data structures and algorithms. We learn programming languages. Similarly, we learn operating systems, right? And also we learn software engineering, artificial intelligence, data mining. So our focus in either teaching these topics per se, or maybe as a student or a scholar we will just focus on just learning these concepts. Now if you can understand the math behind it, say take an example, the data structures and algorithms that has roots in the discrete mathematics. Similarly, the artificial intelligence has roots in the fundamental logic principles, right? So probability and statistics contribute more towards the data mining, artificial intelligence. Now, without these math principles, we will not have any kind of the techniques from either of these, the data mining or an artificial intelligence. So somebody who actually wants to really, become an expert in these areas, whether it is an artificial intelligence, whether it is a data mining, or whether it is a software engineering, computer graphics, vision, information processing. We need to understand the math behind it. If you are able to understand the maths behind it. So take an example. The artificial intelligence. We have the roots into the linear algebra. So especially when you try to give the data in the form of a matrix, the matrix principles, the matrix operations. So these are all comes into the picture. So if we can understand those maths behind these principles, I think we will be able to understand more. We will be able to contribute more. Then research becomes quite easy for us, rather than we think that research is something an Herculean task or a nightmare, or writing an article is the nightmare or something. That will not be a problem until and unless if we have the strong background in these topics. So the list goes. You take any discipline, especially if you see the entire our security. I think all of you are either, if you are a scholar, you must have learned security. If you are a student, you may be reading security, cryptography. If you are a faculty member, you might have taught the cryptography and security. Without knowing number theory, none of our cryptography principles, we cannot, understand. Whether it is a public, especially the public key cryptography, whole public key cryptography is based on the the number theory principles. So if we can understand those concepts, it is very much easy for us, say, to understand how the philosophy of RSA, what is the philosophy of the Diffie-Hellman, what is the philosophy of any other, the public key cryptography algorithm. Not only public key, even with the symmetric key. Say, take an example, the advanced encryption standard, which is based upon the algebraic structure, which is the finite fields. So these are all the things. If we know the principles behind it, understanding the core concepts is little easy. So there is a beautiful paper published in the ACM Inroads, which is available online. This is published in 2013, talking about the role of mathematics in computer science. So I strongly suggest the scholars, especially, and as well as the faculty, to have a look at this around 8 pages article, I think 7 pages article, talking about role of mathematics in computer science, how it is playing a significant role. And not only the mathematics, but the management science, economics, medicine, biology, forensics, linguistics, psychology, philosophers. So you take any discipline, all these disciplines are contributing to the computer science, but at the same time, these disciplines are also getting benefit from the computer science. So it's a two-way handshake. So in one way, they are getting benefit from the computer science growth, as well as computer science is getting benefit from advancements in various other fields. Okay, so we need to understand that. So when it comes to the artificial intelligence and machine learning and the data mining, if we are good in these mathematical aspects, set theory, relations, partial ordered sets, vector spaces, algebra, Hilbert spaces, matrices and tensors. If we are good in these principles, especially, we will be able to solve some of the important problems of data mining and machine learning. So if you look at the artificial intelligence, and this is a beautiful diagram that I've taken from the IBM website. So if you can see, there are various the tasks. Say it is a supervised task, there are semi-supervised tasks and unsupervised tasks. We have several algorithms. Now, all these algorithms are having roots in the mathematics. So we are going to focus upon this, finding the associations, so in the kind of association rules. So that's our focus. We all know about the a priori algorithm that is there in the association for association rule mining. So given a set of transactions, the task of the association rule mining is to find the rules that will predict the occurrence of an item based on the occurrences of other items in the transactions, right? So this is a typical example that we have seen in association rule mining. So there are popular algorithms for doing the association rule mining, which I'm not going to cover now. But my focus is about on using the mathematical lattices. So far we spoke about the importance of mathematics in computer science and the importance of several other fields and how they are contributing to the computer science. So in that, we are going to focus on one of the artificial intelligence or machine learning tasks, which is the finding the association rules and performing the data analysis. Of course, there are algorithms from data mining community, whether it is an a priori rule mining algorithm and all. But our focus here is going to use the lattice theory principles that are there in the matrix algebra. So what are mathematical lattices? Actually are typically used for graphical organization, structural visualization of data, and of course for the knowledge discovery and data analysis. Especially, the main advantage of using the mathematical lattices is to understand the conceptual hierarchies which are hidden inside the data. How can I understand what are the hierarchies which are available in the data? So the mathematical lattices provides a beautiful mechanism for that. So what is the mechanism? The mechanism is the concept lattice. So what is a concept lattice? It's an ordered hierarchy, and it is defined with the help of a binary relation between objects and attributes. Okay, so we are going to define a binary relation. Remember, it is the binary relation is in the very beginning stages of FCA. It was started with the binary relation. Subsequently, we have fuzzy relations. So basically, when it started, it is with started with a binary relation between two sets, which are one is called objects and the other set is called attributes. Now that entire these two sets of objects and attributes and that relation is captured with the help of the data set, which is called as the data set is called as formal context. So we will be going through all these definitions in the upcoming slides. But let us understand that basically a lattice structure, we are going to use it for the purpose of visualization of structure of data, number one. Number two, for the knowledge discovery. Number three is mainly to represent and identify conceptual hierarchies that are there in the data. And for that purpose, we are going to use two sets. One is object set and attribute set. We are going to define the binary relation between them. And all these binary relation, objects and attributes are represented in the help of a formal context. So fair enough, right? So far, we are going in the right pace. Are you able to follow? Shall we proceed, madam?
Yes, sir.
Yeah, yeah. So the lattice theory actually the is represented or the major notation is called formal concept analysis. Which before I start the formal concept analysis, basically what is a lattice? Lattice is an abstract algebraic structure. Okay, so which is containing partially ordered sets. Okay, so a lattice structure contains partially ordered sets. So when you say partially ordered set, that has certain properties. What are the properties of the partially ordered set? The set satisfies reflexive property, antisymmetric property, and then the transitive property. So the lattice structure is going to contain multiple partially ordered, it consists of a partially ordered set in which every pair of elements has a unique supremum as well as a unique infimum, which is called least upper bound as well as greatest lower bound. Okay, so we will don't worry about these definitions. We will be discussing about that in the upcoming slides. So if you understand, basically lattice is an algebraic structure and it contains the partial ordered set, wherein which every pair of element in that set contains a unique supremum and as well as unique infimum, and they satisfy the relation which is reflexive, antisymmetric as well as transitive. Okay. So before we proceed further, let us understand what is meant by a concept, because we said so there are two things. One, I'm simultaneously talking. One, I'm talking about the lattice structure. Second, I'm talking about formal concept analysis. So these two things I'm going to talk parallelly. So you keep these two threads in your mind. So one is about the lattice structure. Second one is about the formal concept analysis. So what is a basically concept? Concept is regarded as a cognitive unit of thought. Cognitive unit of thought, a unit of knowledge. So now let us take an example. Imagine you have a fruit. Fruit has taste, fruit has color, fruit has shape. So typically these are all attributes of the fruit, right? These are all the attributes of the fruit. So how many such fruits? How many fruits we have? We have multiple fruits. Like one, we have apple, we have banana, we have grape, we have mango, we have orange. So these are all called objects. So typically, what we are going to do is we are going to call the concept is a set containing set of attributes or properties. Similarly, the set of objects or entities. So let us take that attributes and objects. So you have objects, you have attributes. So this put together forms a concept. Is it that just I list out the attributes and then just I list out the objects that itself becomes the concept? No, actually concept is a pair. If you see here, so we will go to that. So if you see object, apple, it is related to attributes. Like say it has some taste, it has some color, it has some shape. So the relation between objects and attributes forms a concept. Okay, the relationship between objects and attributes. What is such relation? Basically, it is a binary relation. That means an object has certain attribute or not. And say, take an example, a mango has some particular shape or not, has some particular color or not, has some particular taste or not. So that's what is the relation, binary relation. So now let us do a set of objects is a set of attributes is b, and they having certain relation. So every object that is belonging to this set has all the attributes in B. So that means you have some set of attributes. B is the subset of that particular set, and A is a subset of whole set of objects. So that means you have set of objects here, you have set of attributes here, and your A. Say, take an example. I call this as say some X, some this is as some Y. Your a is subset of X, and this B is subset of Y. So if you take some subset of the objects, which is A, and if you take some subset of attributes, which is B, and if all the elements in this A are related to all the elements in this particular B, then that particular AB forms the concept. That particular AB forms the concept. Okay. Now, while calling what we call this A as extent and B you call that as intent. Okay. So let us take this particular the example. So you can see here from uh, from a set of fruits, from set of their attributes, you take certain set of objects called apple, mango, banana, and particular color, shape, taste, and map them with the binary relation, so that forms a concept. Okay, so this is the basic notion for formal concept analysis, which we spoke about what is a concept. If still you have some doubts, don't worry, we will be dealing with a case study, you will be able to understand. Okay, so what is basically an FCA, formal concept analysis? It's basically a mathematical technique that studies about how objects can be hierarchically grouped according to their common attributes. Similarly, it's a powerful tool for data analysis, information retrieval, knowledge discovery in large databases. See, this is one aspect that you can remember, because recently we have made some contribution towards working towards these large databases. Similarly, FCA is a conceptual clustering method which clusters simultaneously objects and their properties. So this is how you can define what is an FCA. There are multiple definitions, right? And remember, there is another important definition. FCA models units of thought. This is another contribution which we have made here in in modeling the human cognition and memory. So how we can use FCA for that particular purpose. So this also we have done. Okay. So basically, it was introduced by a German mathematician, Professor Willy, in 1982. What is FCA? And yeah, let me take to the one particular example, and so that you will be able to quickly understand. So there are three important definitions that one has to follow: formal context, formal concept, formal concept lattice. So these are the three fundamental definitions one has to understand in this particular. Why we call this formal is it is basically formal means mathematical. Okay, so it's basically a mathematical object. Whatever we are going to discuss is mathematical. So that's the reason why it's called formal. Okay. What is actually a context? Context is a triple wherein which you have set called G, wherein which G is the set of all objects, set called M, where set is the set of all attributes, and I is the binary relation. So all that you call it as the formal context. And you have now a binary relation between the set of objects and set of attributes. We will discuss about the derivation operators a little later. Now, imagine a problem of classifying plants and animals. So take here, look at here in this example. I have set of all objects. What are the objects? I have some dogs, some animals. I have some plants here. So dog, cat, oak, potato, car, water lily, reed. So these are all, I call it as objects, and these are all their properties or attributes. So I'm going to call this as set of objects G, and this column, all the columns as set of attributes M, right? So the set of objects and set of attributes. Now, if you see here, you have set of objects and set of attributes, that is G and M. Then we can notice the relation here. Okay, you can see the relation here. Dog lives on land. So that's why you have some cross indicating that there is a relation. So this is the relation. So here, dog lives in water. So there is no relation. Dog is an animal. There is a relation. It's a binary relation. So either you can say X or you can say 1, 0, 1, 0. Similarly, 1, 0, 1, 0. This is oak. So it lives on land. It's not lives on water. So it's not an animal. It's a plant. I hope all of you are able to follow. So this is called binary relation. Potato lives on land. It doesn't live on water. It's not an animal. It's a plant. Right? It's water lily. Say take an example. It lives in water. It's a plant. So rest it is. So it's a binary relation. All of you are able to follow, madam?
Sir, please proceed, sir.
Yeah. So the point is, when you have this set of objects and the set of attributes and the relations between them, what I'm going to do is, I'm going to pick up a subset. Look at capital A. This is the subset of G. What is G? These are all my objects, right? And these are all my attributes. So I'm going to constitute a set called E. I'm going to have a subset of objects, and I'm going to find an operator called up operator. Okay. What is that up operator is going to find? I'm going to find, the small m belonging to capital M. What is capital M? Is the set of attributes. So I'm going to find out all the attributes wherein which the objects and that set of attributes are having relation. Okay, so let us see what is that. So see here, let me take a subset of G. What is subset of G? I'm taking dog and cat. Dog and cat are coming from the objects. So I'm calling it as A, and A is the subset of G. I'm going to write all the attributes that satisfy the relation with the objects in A. So that means in A I have dog and cat, and I'm going to define the up operator called A up, wherein which I'm going to write all the attributes that satisfying these particular objects. So lives on land, if you see here, dog lives on land and it's an animal. Similarly, cat lives on land, it's an animal. So this is A, and this is A up arrow. Okay. So if you see here, the dog and cat, the objects, lives on land, animal from the attributes. Okay. Similarly, what I am again going to do, I'm going to take lives on land and animal, and I'm going to find out the common objects for these two attributes. Okay, so let me take D, which is the subset of M, right? This is M, my attributes, and I'm going to take a subset of M, again called lives on land and animal. Okay, if I take lives on land and animal, is it that I have my down arrow? My down arrow, what is that? Meaning I'm going to find out objects satisfying these two characteristics or attributes. what that I have? I have dog and cat. Okay. So now if you notice, I have, when I take dog cat, I have these two attributes. When I take these two attributes, I have only these two objects. So now I can call this as the concept because they are, my up arrow, down arrow leading to the common output. Okay, so this is called concept. So my A, set B pair forms concept. So a pair AB is a formal concept if and only if I take A subset of G, B subset of N, and my A up arrow is going to give me B, my B down arrow is going to give me A. That's what is the example we have seen here, right? So such AB I'm going to call formal concept. And remember, it is not that I have only one formal concept, I can have multiple formal concepts. So I find all such formal concepts in the given data. And remember, this particular data, I'm going to call it as formal context. I'm going to call it as formal context. I hope all of you are able to follow. So now we have learned what is the formal context. We have learned what is a formal concept, right? So you see here, so same. So the derived concept is A is equal to B down arrow, B is equal to A up arrow. If such condition or the constraint is getting satisfied, I'm going to call them as my formal concept pair. Okay. So we have these derivation operators in the FCA theory, wherein which that up arrow, down arrow derivation operators, using which we are going to find out all the concepts from the formal context. But remember, for that purpose, there are multiple algorithms in the theory: nearest neighbor algorithm, next neighbor algorithm, next closure algorithm. Like that, we have multiple algorithms in FCA theory to find out the formal concepts. Okay. So again, can we find all the formal concepts in the given table? We have actually found one. So you can have one more heuristic in defining a formal concept. So a formal concept AB, we have actually find out one. Okay, right? So actually it's a rectangular subtable with the row set A and column set B. That is another heuristic definition that what we can give. So now you see here, you take dog cat, you get lives on land animal. And when you take lives on land and animal, you get only dog cat, no other objects. So that pair only you can call it as a concept, right? So do we have each of the two parts determines the other. That's how we are going to call the object set, the attribute set. That means the extent A, the intent B, they should determine each other. Okay. So then only you can call that as a concept. So let us take this particular pair, woke potato, woke potato from the objects and the attributes plant and lives on land. So when you take woke potato and I'm getting lives on land and plant. Similarly, when I take plant lives on land, whether I'm getting only woke and potato, certainly not. If you see here, you have one more object satisfying these two conditions, that satisfying these two attributes, lives on land and plant, which is the reed. So this will not form the concept pair. I hope now you are able to follow with the example. So we have seen the formal definition. We have seen with an example to know what do you mean by a concept. How do you define a concept in the given data table based upon the set of objects and the set of attributes and the binary relation between these two entities, right? So there are various other examples that are there. So you can see here, you can see from the example, this is a data table which we call it as the formal context, and you have objects here, you have attributes here. You can see x1, x2, x3, x4, and y3, y4. It's a concept, because when you take y3, y4, you get only x1 to x4, right? So they satisfy the x1, x2, x3, x4 up arrow, you get y3, y4. Similarly, you take y3, y4 down arrow, you get x1, x2, x3, x4. No other object. So that means a1 and b1 are the concept. Like that, you have multiple concepts that you can get. So from the given table, a given formal context. So this is the formal context that what we have just now seen, and these are all the concepts. Now see here, imagine if I take all the objects in the table x1 to x5. Do you have any attribute or attributes satisfying all the objects? Certainly not. So this is the null set. So even this is also a concept, because when I take all the objects, I have null in the attributes. Okay. Similarly, you see at the down, when I take y1, y2, y3, y4, when I take all, do you have any do you have any objects satisfying all four attributes? Of course, you see here x1. Okay. And when I take x1, is there any other object that is spread across all the attributes? No. So this is the concept. So this is the concept. So you can see inter between C1 to C6, you have multiple other concepts. And if you can observe closely, all these concepts, C1 to C6, they are hierarchically ordered. Okay. They are all hierarchically ordered. This ordering relation is the partial ordering relation. Since this partial ordering relation, they constitute the the lattice structure. So these are all the C1 to C6, C1, C2, C3, C4, C5, C6. All these concepts constitute a structure called lattice structure. Okay. The main reason is that why this is, because if you see here, A1, B1 is the subset of A2, B2. Okay. So let us take an example. What is A1, B1? Okay, if you see here, say take an example. This is the subset of this, and this is the subset of this, right? So this hierarchical ordering relation is making the lattice structure getting defined over the all the concepts, identified concepts. Okay, so you can see that top node groups all objects. The C1 node groups all objects, while bottom node, that means the C6, groups all attributes. Okay, so objects in an extent are inherited from bottom to top. So say take an example, C6, C4, C5. You see here, from x1, you see here from C5, you are going to get objects in the extent are inherited from bottom to top. So take an example. You see here x1, x3 to x5. So these objects, you see here C2, right? C2 got the objects from C1. Similarly, C3 got objects from C1. Now C4 has actually got objects from C2. And similarly, attributes in the intent are inherited from uh, top to bottom. Okay, so this is how actually we define the objects and attributes in an extent and intent, and these extent and intent forms the concepts, right? When you traverse in this structure, we call this specific attributes, and when you traverse up, we are moving towards the general concepts. So that means when we are traversing down from the top to bottom, we are moving towards the specificity, and we are moving toward specific concepts. We are moving up, it is more general concepts. Okay. So there is one more example here, which is there in the multiple books. When you have the data context, how to define the concepts. And remember, this concept hierarchy forms your lattice structure. Okay. So far we have learned what is a formal context, which is the data matrix, which you are having the objects and attributes and their binary relation, the sets of concepts. Then there are hierarchically ordered structure, which is the concept lattice, right? So there are algorithms for generating the concepts, which I'm not going to discuss the algorithms, but upper neighbor algorithm, there are algorithms, right? So which typically, we do it during regular, the workshops where, we can find out the concepts using these algorithms. Now, is it that I have only the concept and concept lattice structure? Certainly, we have one more output from the FCA, which is called an attribute implication. You can see that from the formal context, and when once you have the formal concepts, we can also derive attribute implications. What is an implication? Implication is in the form of A implies B between the sets A, B, where in which in this case, remember, don't get confused. Earlier we have used A for the subset of objects. Now A, B are the subset of attributes. Okay, A and B are the subsets of attributes, and we are going to derive the implication from the subsets of attributes holding in the formal context if and only if A down arrow is the subset of B down arrow. So take an example. You have the particular formal context which we have seen earlier, and this is that corresponding formal concepts. In this particular formal concepts, you can see that y4 implies y3, and that implication is holding in four such concepts. Okay, so you can see here wherever you have y4, you have y3, y4, y3, y4, y3, y4, y3. We have such four such concepts. So this is your support code of this particular application. So what is this y4, y3 here? This is a subset of attributes. Subset of attributes. Of course, you have here only y for one element, but you may be having multiple elements as well. Let's say take an example here. The consequent of the second rule, you have y3, y4. So it's typically a subset of attributes. So y2 implies y3, y4. Y3 implies y4. So these are all the various attribute implications which we can derive from the formal concepts. Okay. So an FCA is actually giving a couple of things. Number one, the formal concepts, what we have defined. Number two, hierarchical structure diagram. Number three, the attribute implications, which are the association rules. Okay, all these rules satisfies the lattice theory properties. Now let us take an example. What we have a case study, where in which there was a data set which we have taken from the healthcare data set. This is about tuberculosis symptoms. These are all the various symptoms of tuberculosis, and uh, for this tuberculosis, the physicians, that means the doctors, have given the expert rules saying that if there is a persistent cough, if there is a sputum protection, if there is a uh, the BS stands for sputum, bloody sputum, and the weight loss, that means it is tuberculosis. So this is your conditional attribute. These are all the conditional attributes, and this is your outcome. So the decision attribute. So you can call them at like this. So now you have such expert rules given. There are about 8 expert rules. When we have the patient's data that is available from the particular data set, and the data set is represented in the form of the formal context, where in which these are all the patients, and these are all the symptoms identified in the among the patients. Okay, so conditional attributes and your decision attribute, these are all the actual data, right? When you analyze this particular data and compare that with the expert rule, and the rules that are provided by the FCA, there is a if you see here, FCA is able to identify some more rules. Okay, FCA is able to identify some more rules which are not part of the expert rules. That means data is providing more instances where the tuberculosis was present, even though that was not mentioned in the expert rules. So this is the patterns identified in the patient data set that is given here, right, by the FCA. So this is the typical use case or the case study with just simple about 21 objects, very trivial or a toy data set. Okay, so that indicates that FCA is able to capture the the hidden structures inside the data. So when once we understood, so far whatever I spoke about is the formal concept analysis theory in terms of a data set that is represented in the form of a formal context with the help of objects and attributes and the binary relation between them. Number one. Number two is how to identify the formal concepts. Number three, about identifying the attribute implications or the association rules between the data attributes. So, and also we have, I've just shown you a case study that was published in the literature about how the FCA is able to identify the attribute implications. So from now onwards, I'm going to talk about what we have done, using this particular. So whatever I said is the very basic fundamentals of FCA. Those who are really interested, they can read more. The field has grown like leaps and bounds. So in 2010, of course, this was for my when I was doing my PhD, when we were actually trying to find out. So this is your lattice structure. Of course, when you put the data in the form of the structure, can we minimize this data? One of the typical problem which you can actually think it as a kind of a dimensional reduction problem. Can we minimize that data so that my lattice structure becomes less complex? That means whether I can map multiple concepts into a single concept. Okay, so in the form of defining the identifying the congruences and then defining the reduced lattice structure. So for that purpose, we actually proposed a method using the fuzzy k-means clustering algorithm. How can we define the, or how can we reduce the concept lattice structure? So if you can notice, that was published in 2010 in the expert system, the application Elsevier journal, which was having at that time about an impact factor of 2.7. So this was the fundamental work that we did it during that period under the guidance of my guide, Dr. S. Srinivas, who was there during the inaugural function of the FTP. So from then onwards, we have done multiple studies. So again, we took that the healthcare data set, and we have applied several of the techniques to reduce the structure of the data or reduce the number of concepts, but at the same time still identify the correlations or to still identify the concepts in the data. So the same data set, and this was the lattice structure. Remember, those who are really interested to understand how this lattice structure has come, there is a tool called ConEXP, which is freely available, and that will help you to draw the lattice structure and understand the attribute implications. So using this structure, we have done these attribute implications and analysis. Of course, we have done the analysis with the help of the fuzzy k-means clustering. Then we have done the analysis with singular value decomposition. We have done the analysis with the non-negative matrix factorization. So all these are all basically fundamentally techniques that are applied over the matrices. So when you view this concept lattice, concept formal context as a mathematical matrix form, and then apply the matrix reduction techniques, but then still you need to see that your expert rules are able to be captured. Not only expert rules, but still whatever the FCA that was able to identify the association rules, that should be preserved. So all that we were able to achieve. So with the help of the techniques that what we have proposed, and those who are really, and in fact, when once we have done this analysis, when we've reduced the structure, and whether we wanted to understand the reduced structure is still holding the association rules and able to capture it. So we have done that verification with the help of two parameters with the specificity and sensitivity. So we are able to achieve the best accuracy. Okay, so that particular analysis was published in the Journal of Biological Systems again in 2010, and subsequently random projections based analysis was published in 2011. This is Journal of Biological Systems, having at that time having the impact factor of around 0.5. Applied Mathematics and Computer Science, which is a Polish journal, having an impact factor of 1.7. So it was published in 2011. Subsequently, clustering-based FCA for the rule mining was published in 2012 in the Applied Artificial Intelligence Journal. And the knowledge reduction with the non-negative matrix factorization was published in the Elsevier Journal on Mathematics and Computers in Simulation. So the point is, you can understand when there is a standard, a rigorous model that is can be used for a data analysis, and if we can understand that model and math behind that model, and understand how we do research about proposing the new models and validating them with the proper metrics, I think the results would go to the fundamentally standard journals, right? Similarly, another interesting problem which I'm showing here is, again, with the help of FCA, what we have done in security, we have an access control model called role based access control, wherein which we define the access control permissions and two different roles. So what we have done is, how can we design the role based access control? Can we use the formal concept analysis? So again, this particular work was published in Security and Communication Networks, which was the Wiley journal at the time. Now this journal has got to Hindavi publishers, but at the time itself, this was having an impact factor of around zero point 0.4. So this I'm talking about 2013. So this was another interesting case study or an application of FCA in a security. When once I did this analysis, what happened. My scholars, we have done a next step of analysis, which is called it as triadic concept analysis. Now, if you notice, this is a kind of an extension. So what happens? We have said two variables. One is the objects and attributes. So it's actually a two dimension. But imagine there is one more dimension called permissions. On what condition a particular object is related to an attribute. Remember, we are bringing the third dimension. So on a particular on what particular permission or on what particular condition an object is belonging to an attribute. If that is coming, that means we are going into the three dimensions. So we have a triadic formal concept analysis. So again, for that purpose, we have algorithms. So what we have done was, again, we have taken the role-based access control, where in which you have the roles, then we have the access permissions, and by the objects. So this particular problem was modeled with the help of triadic concept analysis, and it got published in Journal of Central South University of China, again with this having the impact factor. Then subsequently, this is about triadic concept analysis. Subsequently, in FCA theory, there was one more technique that has come called three-way formal concept analysis. What is three-way formal concept analysis? If you notice the formal context, so far what we said, this is an object, this is an object, this is an attribute, this is an attribute. We were focusing only on an object that is related to an attribute. But imagine if the object does not related to the attribute, we have not focused. So the three-way formal concept analysis is also trying to focus about objects not related to a particular attribute. So there was a beautiful algorithm for identifying the three-way formal concepts. So we have built role-based access control with the help of three-way formal concept analysis. And again, that work was published in International Journal of Machine Learning and Cybernetics, which is the Springer Journal. Now it is having impact factor of about 2. So all the FCA, this is a survey article which we have published in 2016, a comprehensive survey and formal concept analysis, trends and applications. Prem Kumar Singh was my research scholar at the time, and so this was the survey article which we have published. And interestingly, Prem Singh has actually worked on the fuzzy formal concept analysis. Now you see here, the formal context, what I have given here is a fuzzy in nature. That means you have the objects, you have the attributes, but the relation is a fuzzy relation. It's not a binary relation. So we actually asked the questions that can be framed from this fuzzy formal context. How do you represent, number one, bipolar information? how do you represent bipolar information in the sense, you have unipolar fuzzy membership values. If there is a bipolar values, how do you represent? So that is one problem that we have tried to understand. And for that purpose, we are Crimson has come up with the proposal which is called bipolar fuzzy graph representation of the concept lattice, and this was published in the Elsevier Information Sciences Journal, which is a very standard journal having an impact factor of above 5 now. At the time, it was having around 3 or 4. A very standard journal in computer science, a top ranked journal that was published in 2014. Okay, again, Prem Singh work was also on reducing the fuzzy formal concept analysis. Of course, for that purpose, he has used information theoretic approach, which is the Shannon's entropy. This work was published in International of Machine Learning and Cybernetics Journal, again Springer Journal. Now, I've talked about binary formal context. I have talked about fuzzy formal context. Now you have interval valued formal context and the corresponding concept lattice. So how do you represent such kind of data? When you have the data in the form of an intervals, how do you define the context, lattice, and all subsequent analysis, all that? So again, this work is a part of the PhD work of Prem Singh, and was published in 2016 Springer Journal on Soft Computing, again having an impact factor of 3.5 and above. So this was our recent work with the typical industrial application of concept lattice, which is predominantly done with the help of my collaborator Sergio Diaz from Brazil, extraction of the quality behavior rules in the industrial processes. Okay, so it's published in the IOP journal on iOS journal on intelligent data analysis, having an about impact factor of 2. And one of my student, Sumangali, again she got PhD, and she actually worked on concept compression using again entropy based attribute priority, which is again an information theoretic model published in the Applied Artificial Intelligence Journal in 2017. And this is another interesting work which actually we have, I told in the very beginning, how to model cognitive functionalities of the human memory. Okay. So that was the objective we have in our mind. So how do we model the human memory? And for that purpose, first actually we took bidirectional associative memory. If you are familiar with the neural networks, there is a memory model called bidirectional associative memory. So we have taken the formal concept analysis, and then we have brought in the how the concepts of BAM can be modeled using the help of FCA. Again, this was published in the Elsevier journal, Biologically Inspired Cognitive Architectures. Unfortunately, now the journal actually, of course, that was having an impact factor of 0.7, but recently that journal got the stopped, but article is available online. So once we have done that exercise, we have further extended in modeling the various human cognitive relations, various conditions with the help of formal concept analysis and related theories. So this is one of the work published in the Elsevier Journal on cognitive computing, wherein which establishment of cognitive relations with the help of cognitive informatics, we have used actually FCA. Again, three-way analysis for the cognitive memory functionalities. Radhika Shivhare was doing our JRF under project. So this was the paper. And recently, this was the one interesting work, again from modeling the human consciousness with the help of high dimensional. So in fact, so far, whatever is talking about the reducing dimensions, but now we were talking about high dimensional conceptual spaces, where in which we have actually taken the quantum principles and in modeling the human consciousness. So this was also published in cognitive computing. And now, to quickly before I wind up, we have actually worked on scalable models. So far, the standard models that are there in the literature for FCA, they are all experimented with small level data sets of some size, but not at the scalability was a big question mark, or the people were thinking. So there were multiple contributions across the globe. parallelizing and all that. So we actually have done some analysis or the proposals towards making the formal concept analysis, especially the concept generation, implication generation, and again all these things in multiple settings, including the three-way. So these works, just these are the various algorithms we have actually done with the help of Apache Spark. Of course, with Hadoop also, we have some work, even Hadoop, Apache Spark. So these works in generating the concepts, we have come up with various algorithms. These are the various, these are the programming models in the concept for in the Spark for concept generation. We have taken multiple data sets which are the of larger size, and shown that the how these algorithms would perform. Okay. Again, this was published in various journals. Raghavendra is especially now is on the verge of completion of his PhD. So this was his work, how to scale up the formal concept analysis, implication generation, lattice construction, then three-way FCA generation using Spark. Okay. So these are the various works that were carried out. This is the programming model of the work, and this is the very latest article, which is about the distributed approach for calculating the large formal context in the three-way FCA. Okay, so this work was published recently in the Journal of Parallel and Distributed Computing. Again, it's having an impact factor of 4.5. So all the source code of the work, especially the work that was carried out by Raghavendra, is we have made it available in the GitHub. And for